Hello people, in the previous class we knew about different types of functions and the graphing utility of the basic functions. Today we will discuss about the intercepts and symmetricity of functions. So without any delay, let's start our today's class. First of all, we should know what is the term of intercepts, or what do we mean by intercepts. Let's see. The point where the line or curve crosses the axis of the graph is called intercept. মানে কোনো একটা ফাংশনের গ্রাফ যদি আমরা লক্ষ্য করি তাহলে সেই ফাংশনের গ্রাফের যে কার্ভটা সেই কার্ভটা এক্স অ্যাক্সিস অথবা ওয়াই অ্যাক্সিস টু ডাইমেনশনাল গ্রাফের ক্ষেত্রে আর কি যদি এক্স অ্যাক্সিস বা ওয়াই অ্যাক্সিসকে যে বিন্দুতে ইন্টারসেক্ট করে মূলত সেই পয়েন্টগুলোকে বলা হয় ইন্টারসেপ্ট. Okay, we observe this graph. Look at the curve. This curve first crosses the x-axis in this point, and then it crosses -2 at this point, and it crosses y-axis at 3 point. So these are called the intercepts because this curve crosses the x-axis, y-axis. The axis, we know that the point where the line or curve crosses the axis of the graph are called intercept. So here this curve crosses the x-axis at these 2 points and crosses the y-axis at this point. So we can say that these are the intercepts of this graph. Okay, now we learn about types of intercepts. There are mainly two types of intercepts in xy coordinate system in 2D. Obviously it's two-dimensional. Okay, we know about the x-intercept. The x-intercept of a function is the point where the graph of the function crosses the x-axis, and the y-intercepts are the y-intercept of a function is the point where the graph of the function intersects the y-axis. Geometrically, this point represents the values of x for which the function's output y value is 0. And for y-intercepts, this point represents the value of the function when the input x value is 0. In other words, is the value of y when x is 0. Okay, we observe the graphs here. Look at this graph for x-intercepts. Here this curve intersects at this point and in this point for x-axis. সো আমরা জানি যে এক্স অ্যাক্সিসের উপর অর্থাৎ এক্স অ্যাক্সিসের উপরে কোনো পয়েন্টে যদি আমরা কোনো কোঅর্ডিনেট পাই তার মানে ওই অ্যাক্সিসে খালি এক্স এরই কোঅর্ডিনেট আছে, ওয়াই এর কোঅর্ডিনেট ওই এক্স অ্যাক্সিসের উপর অলওয়েজ 0, কারণ আমরা জানি যে অরিজিনে আমাদের পয়েন্ট হচ্ছে 0 0. এক্স অ্যাক্সিসের উপর আমরা যদি রান করি তাহলে আমরা যত আগাবো এক্স এর কোঅর্ডিনেট বাড়বে, কিন্তু ওয়াইয়ের কোঅর্ডিনেট কিন্তু সেই কনস্ট্যান্ট 0, ওয়াইয়ের কোঅর্ডিনেটে কোনো চেঞ্জ হবে না. সো এক্স এর উপরে আমরা যে মানই পাই না কেন সেটা আমরা শুধুমাত্র এক্স এর কোঅর্ডিনেটের ভ্যালু, ওয়াইয়ের কোঅর্ডিনেট অলওয়েজ ভ্যালুজ 0 অন দ্য এক্স অ্যাক্সিস. সো here this curve intersects at the x-axis, so the point is always x0. Y-intercept is always 0 for the x-intercepts. So here are two x-intercepts. This first one, this is the second one. Suppose this value is 2 and this value is 8. So the intercepts are 2 0 and 8 0. That's the concept. And let's see this graph. In this graph, look, this curve crosses the y-axis at this point. Suppose this is a 1. As we know, on the x-axis the y-coordinate is always 0, and for y-axis or on the y-axis the x coordinate is always 0. There is no value of x. As we know, as usual, that at the origin the point is 0 0. So as we consider y-axis, the x coordinate value is always 0 because look, we are going up as we are considering the value on the y-axis. So x value is 0 constant and the y's value is changing. So when the curve intersects at the y coordinate or y-axis, so we get the point 0 y. X coordinate value is always 0 and the y is changing. So these are called the y-intercepts. Look at the point, x-intercepts. On the x-axis the curve intersects at the point which is x0 are known as x-intercepts, and the graph y-axis we say the y-intercept is 0y, because when the curve intersects at the y-axis the x-coordinate is always 0, so the y-intercept is 0y. That's it. Let's find x-intercepts and y-intercepts mathematically. Suppose here a function given y is equal to fx is equal to x square minus 5x plus 6. Now find the x-intercepts and y-intercepts for this function. So as we know, to find the x-intercepts we should consider y is equal to 0, because on the x-axis we know that the y-coordinate value is always 0. There is no y-coordinate of x, it's constantly 0. So if we want to find the x-intercepts, we first consider y is equal to 0. Then y is equal to, we know that x square minus 5x plus 6. So we put it down, x square minus 5x plus 6 is 0. We middle termed it, x square minus 3x minus 2x. Minus 3 into 2, 6. Minus 3 minus 2 minus 5x is equal to 0. X, we should take common x from this one, this part, x into x minus 3. Then we common minus 2 from this part. Minus 2 into x minus 3 is equal to 0. Then the final result is x minus 3 into x minus 2 is equal to 0. Then we find x is equal to 3 from this one, and x minus 2 is equal to 0, and x is equal to 2 from this one. So the x-intercepts are 3, 0 and 2, 0. Two x-intercepts are present here, and it crosses the x-axis. And to find the y-intercepts, we should let x is equal to 0. As we know, on the y-axis, the x-coordinate system always constantly 0. The x-coordinate value is constantly 0, and the y's value changes. So to find the y-intercepts, we should let x is equal to 0. As a result, x is equal to 0. So we should put the values x turns into 0 on these places. So y is equal to f of 0 is equal to 0 square minus 5 into 0 plus 6 is equal to 6. Okay, so I think it's a little dizzy. Here is 6. Y is equal to 6, and the y-intercepts is 0, 6, not 6, 0. Remember the thing very carefully. The x-intercepts x comma 0, and the y-intercepts is 0 comma y. Whereas the y's value is 6, so the y-intercepts is 0, 6, and the x-intercepts are 3, 0 and 2, 0. That's it. And now we came to the most significant topic for our lecture today. The topic is turning point or point of reflection. Let's discuss about this and remember this topic very carefully. Sometimes we saw in the graph that the curve touches the axis. It can be x-axis or y-axis, but don't cross the axis. When the situation occurs, then that point is called turning point or point of reflection. It implies that that particular function must have a repeated root. Okay, now look at the first graph. Here this curve crosses the y-axis. Look, crosses the y-axis at 0, 5 point. So the y-intercept is 0, 5, and this curve or the straight line crosses the x-axis at 8, 0 point, and this is the x-intercept. Look at the thing. The graph or the straight line is crossing y-axis and x-axis, and both are intercepts. One is x-intercept and the y is y-intercept. But sometimes the curve doesn't cross the axes. Look at this one, this graph. This curve goes, and it touches this point, and it never crosses. It touches the x-axis and then reflect or reverse up and goes up. And secondly, look at this point, it crosses y-axis as well and goes down, and this point again the graph touches the x-axis but not crossed it, and again reflects or goes up and goes up. So we can see in this graph particularly that the graph or the curve doesn't cross the x-axis, it touches, and both are intercepts also. It doesn't cross, it doesn't mean they are not intercepts, they are intercepts, but here they touches the x-axis, and here in this graph it crosses the x-axis. And look at this graph, final graph. Here this curve touches the y-axis. Look at this, is the y-axis, and this curve touches this y-axis but never crossed it. Look, never crossed. It touches and reflects again to the right. So here in the first graph we saw that this straight line crosses the y-axis, and this is y-intercept, and this curve touches the y-axis, and this is also the y-intercepts. This is the concept of turning point or point of reflection. When the curve touches the x-axis or y-axis but never crossed it, it means that point is turning point or point of reflection, and both points are intercepts. Don't misjudge it. আবার বলতেছে, ভালো করে বুঝে নাও, একটা গ্রাফে একটা কার্ভ একটা এক্স অ্যাক্সিস বা ওয়াই অ্যাক্সিসকে টাচ করুক অথবা ক্রস করুক, দুইটাই ইন্টারসেপ্ট। যদি এক্স অ্যাক্সিসকে টাচ করে অথবা ক্রস করে ওইটাও এক্স ইন্টারসেপ্ট, অথবা যদি ওয়াই অ্যাক্সিসকে টাচ করে অথবা ক্রস করে ওইটাও ওয়াই ইন্টারসেপ্ট। কিন্তু যখন আমাদের গ্রাফটা এক্স অ্যাক্সিস বা ওয়াই অ্যাক্সিসকে টাচ করবে তখন সেই পয়েন্টগুলোকে আমরা কি বলবো, টার্নিং পয়েন্ট, অর আদার নেম ইজ পয়েন্ট অফ রিফ্লেকশন। এখন কথা হচ্ছে এই জিনিসটা আসলে কখন হয়, কখন আমাদের গ্রাফের কার্ভগুলা এক্স অ্যাক্সিস অথবা ওয়াই অ্যাক্সিসকে ক্রস করে আর কখন টাচ করে। এবার আমরা একটু ম্যাথমেটিক্যালি দেখি জিনিসটা। Okay, now let's observe these two functions. In the first function is y is equal to fx is equal to x minus 2 whole square. And the second function is y is equal to fx is equal to x minus 2. As we know, to find the x-intercepts, we should make y is equal to 0. As on the x-axis, the y-coordinate is always 0, and the constant is 0. X is increasing on the y-axis or decreasing, but y never changes. So, here, when we let y is equal to 0, the function x minus 2 whole square is equal to 0. Then, x minus 2 is equal to root over 0, it means 0. So, x is equal to 2. On this case, same case, y is equal to 0 to find the x-intercepts, and then y is equal to x minus 2, which is 0, is equal to 0, and then we find x is equal to 2. Then look at this. Here we also find x is equal to 2, and for this function we also find the x-intercepts 2, 0, and for this function also 2, 0. The x-intercepts are the same, but the functions are different. Does it make sense? When a function have a repeated root or square, it means the curve of this function touches the x-axis. Or when it's a linear equation x minus 2, no roots here, the root is 1, then it crosses the x-axis. Now let we observe the same thing for getting the y-intercepts. Look at the first function, x is equal to y square, and look at the second function, x is equal to y. Now same thing, to find the y-intercepts we put let x is equal to 0, and then x is equal to y square is equal to 0, and the y is equal to 0. Okay, I think I missed a step here. I think you will understand it. Y is equal to root over 0, and then root over 0 means y is equal to 0, and y-intercept is y is equal to 0. And for this function, x is equal to 0, same thing, to find the y-intercept, x is equal to y is equal to 0, and the y-intercept is 0, 0. Sorry, 0, 0. Now, look at these two functions. The functions are different again, but the intercepts are same. Does it make sense? Why is it here? X is equal to y square. Here we also find a repeated root. And for this repeated root, there are curve of this graph touches the y-axis again at 0, 0 point but never crossed it. Touches this point and then reflects up, reflects right, but never crosses. And for this equation, this is the linear equation as I said, find the y-intercept, we find the y-intercept 0, 0. But look at the graph. Here is no repeated root, the root is 1 here. So the curve of this graph crosses at 0, 0 point, or crosses the y-axis. Does it make sense? When the graph touches or crosses the y-axis, look at the first thing I told you, that when look at this function, we have a repeated root here, the root is 2, and the intercepts is 2, 0 for this function, and x minus 2 is a linear equation, and the x-intercept is also 2, 0 for this function. The intercepts are same, but as we find repeated root here, the graph touches the x-axis for this but never crossed. And this function, we have a linear equation, the root is 1, no repeated root here, and that's why the curve of this graph crosses x-axis but never touches it. Same thing we observe here for the y-axis. When we have a repeated root, x is equal to y square, the intercepts is 0, 0, and x is equal to y for the linear equation, the root is 1, the y-intercept is the same, 0, 0 as this intercept. But as we have a repeated root here, so the curve of this graph touches the y-axis, and we have no repeated root here, so graph touches, so the curve crosses the y-axis, never touches it. That's the thing. So I think now we understand the topic turning point or point of reflection very well. Simply, when we have a repeated root on the function, then the graph or the curve of that function touches the x-axis or y-axis. When we have a single solution, then the graph crosses it, but multiple solution in the same point on x-axis or on y-axis, it means the curve reflects or touches the axis but never crossed, but both are the intercepts. When the graph touches x or y-axis, then those intercepts or those points called turning point or point of reflection. In this graph, it touches the x-axis. Look at the marked points. And for this graph, it touches the y-axis. Look at the marked points. Touches the y-axis. Now we will discuss about the symmetricity of functions. Let's understand the theorems first for testing the symmetricity. First one. The plane curve is symmetric about the y-axis if and only if replacing x by minus x in its equation produces an equivalent equation. It means a plane curve is symmetric about the y-axis. It means you should observe the two sides of the y-axis. Look at this graph. Here is the y-axis, and look at the right side of it, and look at the left side of it. Doesn't it look same, both sides? If you merge at the middle of the curve, which is y-axis, then we will get the same thing on the both sides. Look at this, same thing on the both sides. It means this curve is symmetric with the y-axis. And how will you judge it? Suppose a function is given y is equal to fx, then you replacing the x value with the minus x value on the equation, and then it produces the same equation as before, or it produces the equivalent equation. Then the curve of that graph is symmetric about the y-axis, like this graph. And second one said a plane curve is symmetric about the x-axis if and only if replacing y by minus y in its equation produces an equivalent equation. A plane curve is symmetric about the x-axis. It means both sides of the x-axis looks like same. Look at the first graph. Here is the x-axis and look at the upper side of it and the lower side of it. It looks same, isn't it? Look at this. It's the same and this is the same. So this graph is symmetric. This curve is symmetric about the y-axis or with respect to the y-axis. It means, how will you judge it? If suppose there is a function y is equal to fx, and if you're replacing the y value with the minus y value, and then it produces the same equation as before, or it produces the equivalent equation as before, then the graph is symmetric about the x-axis with respect to the x-axis. Looks like this. Look at this. This is a parabola, and this graph is symmetric with respect to the x-axis, and this graph is symmetric with respect to the y-axis. Look, symmetric about y-axis. And the third one is a plane curve is symmetric about the origin if and only if replacing both x by minus x and y by minus y in its equation produces an equivalent equation. It means if you replace an equation by x by minus x and y by minus y, and then if that function gives you the same equivalent equation or the same equation as before, then you can say that curve of the function is symmetric with respect to the origin. This is the example of a circle. Look, what do you mean by symmetric about the origin? It means if you look around with respect to the origin, you will see same everywhere. Look at this circle. With respect to the origin, the all around scenario is same. It means this curve is symmetric with respect to the origin. Observe these three terms. In the first case, there is the equation y is equal to x square. You all know that this is the equation of a parabola. Then we will replace x by minus x, and y is equal to x by minus x. Then the result is y is equal to x square. After replacing x by minus x, and we observe that the number 1 equation is exactly same as number 2 equation, as 1 is equal to 2. After replacing x by minus x, then this curve is symmetric with respect to the y-axis. Look at the curve. Y is equal to x square. This is the curve, and this is the y-axis. Both sides are similar in above both sides of the y-axis. So this curve is symmetric with respect to the y-axis. And look at this term now. X is equal to y square. This is also equation of a parabola. Replacing y by minus y, then x is equal to y in place of minus y. Minus y whole square is equal to x is equal to y square. And we notice that after replacing y by minus y, the number 1 equation is exactly same as number 2 equation. And as we know, after replacing y by minus y, if we find the same equivalent equations, then the curve of that graph is symmetric with respect to the x-axis. And look at this curve. This graph says that this is the x-axis, and on the both sides the curve is same with respect to the x-axis. And it means the curve is symmetric, or the graph is symmetric with respect to the x-axis. And the final one is x square plus y square is equal to 1. This is the equation of a unit circle. And replacing x by minus x and y by minus y, the finding equation is exactly same as the previous equation. As 1 is equal to 2 after replacing x by minus x and y by minus y, we can say that this curve or this graph of the function is symmetric with respect to the origin. And look at the circle, this one. This is the origin, and all around scenery is same with respect to the origin. It means the curve of this graph is symmetric with respect to the origin. Now we will discuss about the symmetricity of even and odd functions. So look at the first checkpoint. First of all, we know that an even function satisfies the property f of minus x is equal to f of x. It means an even function is symmetric with respect to the y-axis. As we know, by replacing x by minus x, we get the equivalent equation if the curve is symmetric with respect to the y-axis. So, আমরা previous lecture দেখেছিলাম যদি আমরা x এর ভ্যালুকে minus x এর ভ্যালু দ্বারা রিপ্লেস করি and তারপর যদি আমরা আগের ইকুয়েশনের মতো সেম ইকুয়েশন পাই অথবা সেম রেজাল্ট পাই তাহলে সেটা একটা ইভেন ফাংশন as it satisfies the property f of minus x is equal to fx. আবার একটু আগে সিমেট্রিসিটি যাচ করার ক্ষেত্রে আমরা জানতাম যে x এর ভ্যালুকে যদি আমরা minus x এর ভ্যালু দ্বারা রিপ্লেস করি আবার এরপর যদি আমরা সেম ইকুয়েশন পাই তাহলে সেটা সিমেট্রিক উইথ রেসপেক্ট টু ওয়াই অ্যাক্সিস। তার মানে কি দাঁড়ালো, একটা ইভেন ফাংশন অলওয়েজ সিমেট্রিক উইথ রেসপেক্ট টু ওয়াই অ্যাক্সিস, কারণ ইভেন ফাংশন এক্স এর ভ্যালু দ্বারা মাইনাস এক্স এর ভ্যালু দিয়ে রিপ্লেস করার পর সেম ইকুয়েশন আর সেম রেজাল্ট প্রডিউস করে। আবার সিমেট্রিসিটি যাচাইয়ের ক্ষেত্রে আমরা দেখেছি যে এক্স কে মাইনাস এক্স এর ভ্যালু দ্বারা রিপ্লেস করার পর যদি সেম ভ্যালু প্রডিউস করে বা সেম ইকুয়েশন প্রডিউস করে দেন ওটা ওয়াই এর সাপেক্ষে সিমেট্রিক। সো by merging these two relations, we can say that an even function always symmetric with respect to the y-axis. For example, f of x is equal to cos x. This is an even function. Why? If we replace the value x by minus x, then is equal to what? Cos minus x is equal to cos x. So it satisfies that property. An even function satisfies the property. This property satisfies. Look at the graph of f of x is equal to cos x. This is the y-axis and look at the left and right side. Both sides are looking similar. If we merge y-axis, then it is symmetric with respect to the y-axis as it also an even function. And that's why we can say that an even function is always symmetric with respect to y-axis, as the graph of cos x an even function and the curve of this function is symmetric with respect to y-axis. Okay, now let's look at the checkpoint 2. If we notice the checkpoint 2, first of all, we know that an odd function satisfies this property f of minus x is equal to minus fx. It means an odd function is symmetric with respect to the origin. As we know that by replacing x by minus x and y by minus y, we get this equivalent equation if the curve is symmetric with respect to the origin. Previous lecture আমরা দেখেছিলাম একটা odd function এর ক্ষেত্রে যদি আমরা x এর ভ্যালুকে minus x এর ভ্যালু দ্বারা রিপ্লেস করি তাহলে সেটা minus fx এর মতো রেজাল্ট প্রডিউস করে। সাপোজ f of x যদি একটা ফাংশন হয় এবং x কে যদি আমরা minus x এর ভ্যালু দ্বারা রিপ্লেস করি তাহলে ফাইনালি সেটা f of x আসে না, আসে minus of f of x। আবার একটু আগে সিমেট্রিসিটি যাচ করার ক্ষেত্রে আমরা দেখলাম যে x কে যদি মাইনাস x এর ভ্যালু দ্বারা আমরা রিপ্লেস করি আর y কে যদি মাইনাস y এর ভ্যালু দ্বারা রিপ্লেস করি তাহলে ওটা সিমেট্রিক উইথ রেসপেক্ট টু দ্য অরিজিন, মানে মূল বিন্দুর সাপেক্ষে সেটা সিমেট্রিক। ডাজন্ট ইট দ্য সিমিলার থিং? যদি আমরা x কে মাইনাস x এর ভ্যালু দ্বারা রিপ্লেস করি তাহলে আমরা মাইনাস y পাইতেছি f of x থেকে। তার মানে কি দাঁড়ায় f of x is equal to y. If we replace x by minus x in a function or odd function, we will get minus y, as we will get minus f of x. And on the other hand, we know that if we replace x by minus x and y by minus y, then we say that the curve of that graph is symmetric with respect to the origin, as an odd function satisfies the equation f of minus x equal to a minus f of x. মানে x এর ভ্যালুকে যদি মাইনাস x এর ভ্যালু দিয়ে রিপ্লেস করি তাহলে y এর ভ্যালু মাইনাস y এর ভ্যালু আমরা পাবো, y এর বিপরীতে আমরা মাইনাস y এর ভ্যালু পাবো। সো আমরা বলতে পারি একটা অড ফাংশন উইথ সিমেট্রিক উইথ রেসপেক্ট টু দ্য অরিজিন, কারণ অরিজিনের সাপেক্ষে সিমেট্রিসিটি যাচ করার জন্য আমার x কে মাইনাস x এবং y কে মাইনাস y এর ভ্যালু দ্বারা রিপ্লেস করলে আমরা সিমেট্রিক অর ইকুইভ্যালেন্ট ইকুয়েশন পাই as previous. So look at this example, f of x is equal to sine x. This is an odd function. Why? If we replace x by minus x, then we will get sine bracket of minus x is equal to minus sine x, which satisfies this property. And we know that if an odd function satisfies this property, then it also satisfies the symmetricity test with respect to the origin. It means an even function is symmetric with respect to the y-axis, and an odd function in this case is symmetric with respect to origin. Then look at this graph. This is the graph of sine x. Look at this is the origin, and look at the around scenario of this graph. This graph is clearly symmetric with respect to the origin. There we say, as f of x, sine x is an odd function, it satisfies the property f of minus x is equal to minus fx. So its graph, or the curve of this graph, is symmetric with respect to the origin. And that's the concept. Thank you.